Here's a question where we're looking for a percentile situation. And so we have this population, we're normally distributed. Let me switch to a pen here. We have a mean of 28, standard deviation of 59.2. Our sample size is given as n equal to 71. We're looking for, in this example, here's our kind of normal symmetric curve, something like this. Our mean is at 28. We're looking in this case, when we have a percentile, the 11th, that P11 means that 0.11 is the area below the line, and 0.89 is all this area above. And so we want to know what this x is for single values and then also for sample means. So when we are looking for the x value and we're given the percentage, what we want to do is use the inverse normal calculator. So here I'll go to, let's see if I can find that. What did I do? There it is. Okay. So here's our inverse normal calculator. If you type in online stat book inverse normal calculator, make sure at the top here under the menu we have inverse normal. And we want, let's see, our area below is 0.11. Our mean in that case was 28. We want the area below. And in the first question, what we're asked is for single values. And so for single values, we're just going to use our regular standard deviation of 59.2. So our standard deviation here is 59.2. And this will give us the value. So our value here is negative 44.6. Let's see how many decimals it says. Round to 1 decimal place. Yeah, so that was 44.6. So that's our value here. Let me switch to the version that I can write on. And so here, actually that was a negative, right? We'll get back. Sorry, I have a lot of windows pulled up. Negative 44.6 is what we're looking for. All right. So we want negative 44.6 here. That was already, oh, scroll down a little bit, but that was already listed there. So let me see if I can scroll up a bit. All right, so then the next question is separating the means. All right, so when we're talking about sample means, that's where we have to take that standard deviation right here, this 59.2, and we want to say 59.2, let's see if I can find my pen, 59.2, and we want to divide by the square root of 71. So we have to adjust that standard deviation for the sampling distribution. And let's see if I have a calculator. I'll bring one up here. There we go. All right, so I'm going to clear that out. We'll say 59.2 divided by the square root of 71. That gives me 7.0257. That's kind of a long number. I want to make sure I use several digits so that when we round at the end, it's pretty accurate. Okay, so I'm going to take that standard deviation now that I've adjusted it, put that into my calculator. That's 7.025747 was our number. And so now it's the same situation. We're still looking for 11% below, and the mean is still 29 or 28. So this time I have 19.4. So we were rounding to 1 decimal place there, so it would be 19.4, and that's going to be that second answer here. Let's see. There we go. 19.4 would be our cutoff in the case of sample means. So hopefully that's helpful. I think the key to this one is using inverse normal. If you're using the regular TI calculator rather than the online calculator, in this case you want to go to, let's see, I can pull that up and show you real quick just to make sure. So we would go to second vars, which is distribution, scroll down to inverse norm this time. In this case, we want to put the percentage, so that would be 0.11 for each case, comma, 28 is our mean, And then in the first example, again, we used 59, let's see, what was it, 59.2, because it was for individuals. That's going to give us that same amount back, negative 44.6. And then we do the same thing for sample means. We'll do 0.11, comma 28, comma, and I think you can type this all in. So I think you can just say 59.2 divided by the square root of 71, and then I want 2 parentheses, and that should do it. Yeah, that gives us that 19.4. So that's 2 ways to do it, depending on which technology you're using. And if you have further questions, go ahead and send me an email and let me know. Thanks.